This is important to remember. The maximum or minimum value of a quadratic function is always going to occur at the vertex. If you've got a parabola that opens up, in which case A is going to be greater than 0, A is a positive number, then the vertex is a minimum. If you've got a parabola that opens down, where A is a negative number, A is less than 0, then you have a maximum. So we've got a max here, got a minimum here. Let's see how this could be used. Take a look at this problem. Find the maximum value of f of x equals a negative 1/2 x squared plus 3x minus 5. The maximum value, because this has a negative a value, it's negative 1/2 x squared, and a is always the coefficient of the x squared. So the maximum value, the x value, will be negative b over 2a. That's going to be where it occurs. So in this case, that would be negative 3 over 2 times a negative 1/2. So we've got negative 3 over 2 times 1/2 is 1. So this is a negative 1. So it's positive 3. So don't panic if you see a fraction. And f of 3 is negative 1/2 times 3 squared plus 3 times 3 minus 5. Negative 1/2 times 9 plus 9 minus 5. Negative 9/2. Positive 9 minus 5 would be a positive 4. Well, that's 4 over 1. I can get a common denominator by multiplying by 2. So we've got negative 9/2 plus 8/2 would be at negative 1/2. So the maximum is negative 1/2. And it occurs at x equals 3. In other words, the vertex for this is at the point 3, negative 1/2. We know this opens down. So the graph negative 1/2 would occur somewhere around there. It goes down. So the graph's going to look something like that. We not only know it goes down because it's a negative, but we know it'd be a comparatively shallow graph because it's going to be pushed back toward the x-axis by the 1/2. Let's look at another one. If a ball is thrown directly upward at an initial velocity of 40 feet per second, its height in feet after t seconds is given by f of t equals 40t minus 16t squared. Okay, that we need. F of t equals 40t minus 16t squared. And by the way, anytime you see an equation where gravity has anything to do with it, if it's in feet per second, it's going to have this negative 16t squared because that is the acceleration caused by gravity measured in feet per second. They want to know what is the maximum height obtained by the ball and when does it occur? That is the vertex. So first of all, we need to find the vertex. We're going to have t, in this case, equals negative b over 2a That's going to be the when. That's a t-value. So it's a negative. Now, these are written backwards. This is B, this is A. A is the coefficient of the squared variable. B is the coefficient of the variable raised to the first power, and C would be the constant. So B is 40, so negative 40 over 2 times A is a negative 16. Negative 40 over a negative 32 is going to be, they both divide by 8. The negatives will cancel out and make it positive, so that would be 5 over 4. So 5/4 seconds. So the x, or in this case, the t value from the vertex is 5/4. The y value we would get by plugging that back in. So f of 5/4 is going to be 40 times 5/4 minus 16 times 5/4 squared. Okay, this cancels. 40 over 4 is 10, so this is going to be a 50 minus 16 times 25 over 16. Well, the 16s cancel, so it's 50 minus 25 is going to be 25. So the y value is 25. So the answer to the first question, what is the maximum height obtained by the ball and when does it occur, is the max height is 25. This is in feet. And occurs at t equals 5/4. So 1 1/4 seconds into the flight. When it says when does it hit the ground, what is the height when it hits the ground? Well, the height at that point, f of t, is going to be 0. So we want to know when f of t is equal to 0, or when 40t minus 16t squared equals 0. If I factor out 8 and t, that's going to leave a 5 here, minus 2t equals 0. You can use the quadratic formula on this. If you have any trouble factoring, just use the quadratic. 8t is equal to 0 when t is equal to 0. 5 minus 2t is equal to 0 when negative 2t equals negative 5, or when t equals, if I divide by a negative 2, I'm going to get 5/2. So that's at 2.5 seconds in. So it hits the ground. Well, initially it was on the ground. That's at t equals 0. But that wouldn't actually be hitting the ground because that would be the starting point. So I would say it hits the ground at 2.5 seconds. Let's look at one more. A manufacturer finds that the revenue generated by selling X units of a certain product is given by R of X equals 80X minus 0.04X squared, where R of X is in dollars. What is the maximum revenue, and how many units must be sold to achieve this? So the maximum revenue occurs where? At the vertex. And all the examples we've done is dealing with maximum, but minimum works exactly the same way. It will always be at the vertex. So to find the vertex, we're going to use x equals negative b over 2a. And again, 80 is b, negative 0.4 is a. because B is the coefficient of the X, A is the coefficient of the X squared, and this doesn't have a constant term. If it did, that would be C. So negative B is negative 80 over 2 times, this is a negative 0.04, negative 80 over negative 0.8 is going to be 2 negatives cancel. 80 over 0.8 is the same thing as 800 over 8 if I multiply both of those by 10. So that's 100 units. So we have to sell 100 units, and the revenue generated by selling 100 units is going to be 80 times 100 minus 0.4 times 100 squared. It's going to be an 8 with 3 zeros minus 0.4 times a 1 with 4 zeros, because squaring it'll double that. So 8,000 minus 0.4 is going to make this 4,000. 8,000 minus 4,000 is 4,000. So selling 100 units will produce the maximum revenue of $4,000. All right, and those are several examples of how to take a quadratic equation and find the maximum or minimum value for it.